Hello everyone, welcome to this video. In this video, we are going to learn about random forest using OpenMathAI. So, let's get started. What is random forest? Random forest is a supervised machine learning algorithm used for both classification and regression problems. Unlike a decision tree, which makes predictions using a single tree, random forest builds multiple decision trees and combines their predictions to produce a more accurate and reliable result. For classification, it uses majority voting, while for regression, it uses the average of all tree predictions. Random forest creates multiple trees using random samples of the training data and a random subset of features. Since each tree learns different patterns, their combined prediction reduces overfitting and improves overall accuracy. Imagine you want to predict whether it will rain using features such as temperature, humidity, wind speed, atmospheric pressure, and cloud cover. Each tree may focus on different weather conditions and make its own prediction. Finally, random forest collects a prediction from all the trees and selects a class with the highest number of votes. As a result, random forest produces more accurate and stable predictions than a single decision tree and is widely used in weather forecasting, disease diagnosis, fraud detection, customer churn prediction, and loan approval. We will use this dataset for the random forest model. So let's get started. Open OpenMathAI. In this demonstration, we use the rain prediction using random forest model. Click Create New Project. Enter the project name as Rain Prediction. Choose a folder location to save the project, then click Save. To import your dataset, either click Load Example Dataset or browse for dataset to import your own CSV file. Once the dataset is loaded, verify that it contains all columns before proceeding to model training. Scroll down to view the first 10 rows of sample data. Click Continue to Configuration to proceed. Configure the dataset by specifying the input features and output target. There's also a feature called Ignore, which can be used for columns that should not participate in model training. Select the input and output columns manually, or use Smart Suggest for automatic recommendations. There's one more feature, Signal Diagnostics. There's 3 columns. First one is column. It tells which features are in the dataset like inputs and outputs name. Second one is VIF. It tells how much correlation of the features. Third column is status, if it's okay, moderate, high, redundant, and constant. Review the selected configuration. Click Proceed to Model Design. Choose a model from the available machine learning models. OpenMathAI recommends suitable models and features based on the dataset. For this demonstration, select the random forest model. View the model overview, pros, cons, and real-world applications. Click Proceed to Training. You will see the selected model. Click Start Train Models. Review the training configuration. Test data split, which determines a percentage of data reserved for testing and validation. Review the model parameters and pre-processing settings. And also the another feature is added that is trained from scratch or continue from use model. If you train this model before you use that option. Modify the configuration if required. Click Start Training to begin the training process. After training is complete, review the following performance metrics. R-squared measures how well the model explains a variation in the output data. Range 0 to 1. MSE, mean squared error, measures the average squared difference between actual and predicted values. RMSE, root mean squared error, the square root of MSE. RMSE is expressed in the same units as the output variable, making it easier to interpret. Engine time, the time required for the generated model engine to execute and produce predictions. Lower engine time indicates faster model execution, which is important for embedded systems and real-time applications. Fit quality, an overall assessment of how well the model fits the dataset. It is generally derived from metrics such as R-squared, RMSE, and residual errors. Model accuracy. For regression models, accuracy is commonly estimated using the R-squared value. Example, R-squared equals 0.95 accuracy, almost equal to 95%. Click Fit to Window. You will see 3 types. Fit to Window, comfortable, compact. Then the clear history if you click that it will clear the history before its trained model. Another is deselect and select all trained models for export. Click View Curves. You will see the diagram of R-squared residuals and residuals diagram. Click Math and Code Preview to view the mathematical model generated by OpenMathAI. The preview displays a mathematical equation, the corresponding source code, and a detailed explanation of the generated expression. Open the Math view to visualize the expression tree created from your training data. Maximize the Math view window and scroll down to see the complete tree, especially for complex models. The expression tree shows how the model combines input features and mathematical operations to make predictions. Once the tree is generated, OpenMathAI uses a learned mathematical relationship to predict outputs. For new input data without retraining the model, return to the results page and click Deploy Status. Click Export Model. Choose the required export format. Answer C. FMU 2.0, FMU 3.0, Verilog RTL, VHDL RTL, Python Bundle, ONNX Hub. You can choose any of these formats and export. You can also download the free trial versions of OpenMathAI and Twin Simulate. Thank you. Stay tuned for more OpenMathAI demonstration.